And welcome to today's webinar. This is part 2 of a 4-part cardiogenic shock registry research series called PMP, the Nuts and Bolts. My name is Melissa Clark. I'm the research project manager for the cardiogenic shock registry. Before we get started, I'd like to go over some housekeeping items and let you know how to participate in today's event. Although there are no CEs for today's webinar, all attendees of the live event will receive a certificate of participation along with the recording within 2 hours of the conclusion of the webinar. And this will come via email. The presentation is also available as a handout, and you can download that handout via the handout pane in the control panel. You'll have the opportunity to submit text questions by typing them into the questions pane of the control panel. You may send your questions in at any time during the presentation, and we'll collect these and address them during the Q&A session at the end of today's presentation. If you experience any technical difficulties during the presentation, most can be resolved by refreshing your browser. If it doesn't resolve with your browser, please log off and then log back in, but try to use the Chrome browser. That works best with this platform. You may also refer to the GoToWebinar customer service. Their information is in your confirmation email. Our panelists today are our co-chair of the Cardiogenic Shock Registry and the director of the Cardiac Intensive Care Unit at Brigham and Women's Hospital, Dr. David Morrow, along with their biostatistician, Michael Palazzolo. Also joining me are 2 of my colleagues from the AHA, Pratik Malia, who will provide an overview of the PMP, and Kylie Corbin, who will run through the CRF during a live demo. At this time, I'd like to welcome Dr. David Morrow to begin today's presentation. Thank you.
Yeah, thank you very much, Melissa. And I'll just echo the welcome to everyone. We really appreciate your joining. We hope that this second in the series of webinars for the registry will really be helpful to you. Both the disclosures for myself and Michael are on this slide, and they include research grant support that relates to cardiogenic shock. If we could go to the next slide. And so I think actually Melissa already introduced me, my pleasure, and we can go through the next slide as well. It'll be available in the handout, and I'll say that Michael has terrific experience working in the PMP with the Get With The Guidelines registries, and he'll be able to give you some firsthand experience of what it's like to run analyses. We're very grateful for him being able to join today. Next slide. And so first on our agenda is I'm going to hand things over to Pratik Malia to really walk you through what all the PMP has to offer to you. And we're going to spend really the session today trying to give you a little bit of a hands-on version of the way you can use the PMP for your research, and then talk next about how to engage in the research opportunities through the Cardiogenic Shock Registry. So Pratik, the floor is yours.
Thank you, Dr. Morrow. Hey, everybody. My name is Pratik. I'm part of the data science team at the American Heart Association. I'm going to give you a brief overview of the precision medicine platform, or the PMP, and how it can help facilitate your research. A bit of background first. So the PMP was developed by the Heart Association to enable the processing and analysis of Get With The Guidelines registry data. Over the years, its capabilities have expanded to support newer programs and registries, more complex analysis, modeling, and data management in a secure cloud environment. The PMP plays a crucial role in furthering the association's research goals by improving scalability, discovery, and impact, while also providing collaborative infrastructure and access to quality data and real-world evidence generation. We've highlighted some of those areas on this slide. In addition to that, the PMP also helps the association in supporting researchers through conducting data bootcamps and research awards, data challenges, and promoting self-analysis for registry research. Investigators, researchers, and grantees are using the PMP for analyzing data with over 800 papers published on Get to the Guidelines registry data and over 500 publications from the association's grantees. So in short, the PMP is a cloud computing platform and data marketplace that features AHA datasets. It allows teams to easily collaborate, securely access and store data, and utilize computational tools for analysis and research in virtual workspaces. Like mentioned before, the PMP serves as a data marketplace for AHA datasets. You can find and request access to these in a secure workspace with an approved research proposal. Please visit pmp.hart.org/request for a full list of all available datasets. I'll next go over some of the features of the platform in more detail. A brief overview first. The PMP portal allows users to submit different dataset requests. It allows them to access documentation. It allows them to create and share workspaces with their team, upload and export files, adjust different configurations of their workspace applications, and submit support requests. This is the page from where a user would launch their cloud workspace. Coming to the workspace itself, the workspace allows teams to access datasets. It allows them to write code, view tutorials, and install analytical packages. The platform currently supports the usage of JupyterLab, RStudio, and SAS Studio, and users can seamlessly switch between multiple applications as needed. Each workspace also comes pre-installed with a set of commonly used packages for data analysis and modeling. Users can also install other packages or libraries as needed. Dataset documentation like data dictionary and coding instructions, etc., are accessible from the workspace portal page. They are found under the datasets tab. To request access to a workspace, you will first need to have an approved non-disclosure and data use agreement. Users can then log in or register into the PMP and follow these instructions. If you're part of a team, only one person needs to request the workspace. They can then share that workspace with the rest of the team. So the instructions are on this slide. So you would log in with your user account, go to the data page, find the Cardiogenic shock data set, select it, and then click on request workspace and data. It will then lead you to a form that you would need to fill out. Please fill out all the required fields and select the applications that you choose to use. You can select multiple if you're working with multiple languages, or select the ones as needed. Your request will then be reviewed and approved by the administration team. Please note that any request that you submit, be it for workspace, dataset, a configuration change, or for share, all requires approval from the AHA admin. I say this to keep in mind because these are usually approved during business hours. So requests that are submitted on the weekend or holidays will be reviewed on the next business day. You will, of course, receive email confirmations throughout the process. You will receive email confirmations when requests are submitted, approved, when a workspace is shared, as well as for applications start and stop. Sharing the workspace is also very simple. It is also done via the portal page. It is done by the users tab. So workspace owners can go into the users tab and then click on the red share workspace link. It will open up a dialog box from where you can enter the email ID of the person with whom you would want to share the workspace with. You can adjust additional permissions to that person, and once you click share and the share request is approved, the person will receive an email notifying them as such. To launch different workspace applications, you would go to the Applications tab on your workspace. By default, the applications would be in the stopped state. Once you click on the red play button, it would change the status from stop to start in progress. And finally, once the computational instance is up and ready to be launched, the status will once again update to running. The entire process should take around 3 to 4 minutes. And if you have notifications enabled, you will also receive an email when your workspace is ready to use. Here's a look at the Jupyter Lab application from within the workspace and the folder structure. The structure is same within RStudio and SAStudio as well, where we have a central files folder and a bunch of subfolders. Now, these subfolders all perform unique functions. The first one is the uploaded files folder. This folder contains all of the files that are uploaded into the platform. I'll go over how to do that shortly. Then we have the export files folder. So any files that are copied to this folder can be exported from the platform. Again, to preserve data security, only specific file extensions can be exported from the workspace, meaning data sets themselves cannot be exported, but the results from your analysis can be. The third folder is the runbooks folder. This contains our runbooks or tutorials that can help you get started with loading data. And finally, we have the workspace files folder. And this one you can think of as your working directory. That is where you should be storing all of your intermediate data sets as well as your code that was created for your analysis. So to upload files, you would go to the PMP portal page, you would go to the Files tab, and there would be two sub tabs in there, one for upload and one for export. For upload, there should be a red upload link, and that would open up a dialog pop-up where you can drag and drop different files, and then it will synchronize to your workspace application once uploaded. Similarly, the export files tab lists out all of the files that are eligible for export that you have placed in your export files folder, and you can go to each individual file and then click on the actions ellipses that can help you allow you to download those files to your local computer. As mentioned before, only specific file types can be exported from the workspace. No datasets can be exported, but PDFs, HTMLs, etc., images, as well as your code files can be exported. Some few minor details before we end this section. So here is a list of some of the pre-installed packages for both Python and R. We have more information on the pre-installed packages on the link on the slide. The webpage also has a comprehensive user guide that details all the information that I presented today. You can access the user guide from the support menu. For technical support requests, you can also use the support menu to report any workspace issues. We also have weekly office hours to help address user questions. The links to these office hours are found on the PMP homepage. And finally, if you have any general questions about the PMP or the data, please reach out to us at pmp@heart.org. I hope this was a helpful overview of the precision medicine platform. I'll turn it over to Michael to talk about his experience working with the cardiogenic shock registry on the PMP. Thank you.
Great. No, thank you very much, Pratik. That was really terrific. And maybe I'll just highlight that it shows what an amazing platform the PMP is for collaborative research. It gives you direct access to the data sets that are relevant for the work that you're doing. So you're not having to work through some external party, but it allows you to actually, within that cloud environment, have direct access to the data that you need. It really gives you a collaborative community for your whole team to be able to work together within the PMP. And then, as Michael may speak to as well, it also offers the opportunity to share and learn from other groups that may be working within the registry that have already developed some code to get to specific subpopulations or create derived data sets that may also be relevant to your practice, to your analyses, and it has an enormous wealth of applications that you can use. So you have virtually everything at your fingertips that you might need to analyze the data set. So it really is terrific. I do want to encourage people, if you have questions, please drop them into the chat, and then we'll circle back at the end. Michael is first going to give you a little bit of just a high-level overview of what it's like to work within the PMP, building on everything that Pratik just described. And then Kylie Corbin will take you through a tour of the CRF, just to give you a reminder for those of you who haven't been living in it, the types of data that you will have available to you so that you can think about how you might incorporate them into questions that you want to ask of the registry and the analyses you want to do. So with that, a preamble, I'll turn things over to Michael. And again, I encourage you to put any questions you have in the chat. So Michael, floor is yours.
Great, thank you, Dr. Morrow. We can go to that first slide with control. So just a little bit of background about my experience with the registry. I've been using the registry since early 2024, and I've really worked on three main projects with clinicians. One was the vasoactive medications, which was presented at AHA in 2024, and we actually published recently in October 2025 in JAHA. And then another one was looking at Sky Shock, which was presented at AHA 2024 as well. And another one was looking at shock teams. So some of the key variables that we've really used for these analyses, and that I've really kind of dove into in the registry, involve patient demographics, medical history, medications at the time of shock onset and serial medications, and then admission and shock onset labs, along with Sky stages and SHARC definitions. A lot of these are looking at one of our main outcomes that we look at is hospital mortality. Next slide. So just a little bit about reading in the data and kind of how that went for me. I'm more of a SAS user with limited amount of R experience. So you can create the data set using provided R code that's provided in the registry and save that as a CSV file. And I thought it was really nice since it kind of, there's instructions within that code that kind of walk you through it. An example is kind of below of the code that's generated. So even if you're not really an R user, it's pretty easy to walk through and save it as a CSV so that you can import it within a program maybe you're more familiar with, like I was with SAS. And then one of the points that I wanted to make is you may need to manipulate some of the variables in the data set. So it's important to take some time to kind of go over these variables and kind of see their structure. So for example, I have medical history, race, and age, where you can see they're more in a list format. So in the ECRF, they are actually multi-select variables. So if you wanted to kind of look at some of these variables in a more binary sense as a yes, no, to include in a model, look as a subgroup, or even maybe look at these as an outcome, you're gonna have to do some data manipulation in order to kind of structure your data so you can more easily use that.
And Michael, before you go on, just where do you find the code in order to be able to export to CSV so you can use in SAS?
It is provided to you. Yeah, so the R share book, you can download that code, you can copy it, you can change anything that you need in the code, and then you pretty much just run that little snippet, and then it'll save as a CSV, and then that will be in your data sets to where you're able to import it into SAS.
So it's within the R share book on the PMP.
Correct.
Okay,
Yes.
great.
Yep. So a little, I'll speak more to the SAS side of this. I've been, for a lot of these analyses, saving all these as PDF documents, and you're able to do that using ODS commands. And I will point out that you will need to put these in the export files folder that Pratik mentioned earlier. And it does take maybe a few minutes after running the code and the PDF's printed to pop up there. So once you run those, it'll pop up those, and then you can use under the actions to be able to download that onto your desktop, where you may be able to share it or even import the PDF in an Excel and make any modifications that you might need. So I thought that process was very straightforward and simple into exporting the data, getting it off the platform so that you could share to whichever clinicians you may be working with or others. So kind of an example of my file structure. So as Pratik mentioned, I kept all my project and folders in SAS code in the workspace files. And part of that was that data folder that you see below was really where I took time to review the data, to manipulate the variables that I have so that I had kind of my own version of a derived data set with all these variables that are needed for additional projects so that you're not having to do it every time for an additional project. And then just pointing out the export files too, to where when you can run the code and then export the files there. So that's what within SAS this kind of looks like when I'm working on projects. I'll have folders for different projects and SAS code within those folders. Next slide. So just a general overview, I've had a very positive experience using the cardiogenic shock registry. Thought the data was very easy to access, especially as a person who's not too familiar with R. It was easy to access, the data was easy to manipulate. And it's really nice that there's multiple programs available to use in the platform. In a new upcoming project that we're working on, there's some functions within that aren't available within SAS, so I will need to jump over to R. So it's nice to be able to kind of go back and forth between the two, and it really gives flexibility of what you can do. And it's great that the registry keeps going. You know, as statisticians, you know, we love data. So the more data, the better. The registry keeps going and updating. So the more data I have, the more that we can do with that. So just general advice of key takeaways through my time. Really take some time to review the data. There are code books and ECRFs provided that really help the communication between, you know, maybe statisticians and clinicians, where clinicians can point out, you know, maybe this part of the ECRF we're looking for a variable, and that does translate directly to the code book. So it's very easily to kind of go back and forth between those. So really taking some time to just understand the data and the way the platform works is very beneficial in the long run. And then there are also weekly office hours for questions about navigating the workspace and applications, and also a nice user guide that kind of lays out the importing the data and some other general questions that they might have. That's a great reference for future use. So, and with that being said, I think that's the end of my slide. I just like to thank AHA for having me on here today.
Yeah, no, thank you very much. We'll turn over to Kylie in just a second. Maybe, Michael, are there any, because I imagine we have a very broad audience on the line today. Some will be the clinical teams like me, and then others will be maybe the statistical groups at the sites. And definitely, as someone asked in the chat, you will have the slides available to you, have the recording available to you. And so if there are members of your team that aren't on that you realize this would be really helpful for, they'll be able to look at it in the future. And Michael, were there any pain points that just from getting, when you first started getting going, that it's useful for people to know about in advance? Or was it all smooth sailing from moment one?
I guess one of the pain points is kind of looking at missingness, especially with this type of registry data of, you know, different sites might not collect certain information or so. So especially with like lab values, to kind of take a look before you jump in, because especially in like a modeling sense where models use complete case scenarios, if you have all these medical history variables that have very little to no missingness, and then maybe throw in a lab value that only maybe has, you know, 1,000 or so patients, that really kind of in the background cuts down the amount of patients that are considered in that. So kind of being cautious with that. There's also, for some lab values are recorded in different units. So to kind of keep in mind going through those and really just taking a deep dive into, you know, those code books and kind of seeing what you can do. But once you create kind of, at least in SAS, what I did was create a macro for a lot of those list formats. It took me a little bit to figure out one that I liked, but once you kind of do that, there are, you know, 5 or 6 list format variables that we've used on projects to where I just applied that macro to easily create those binary variables. And, you know, kind of, I think you started first project with maybe looking at 2 or 3 of those, but now, you know, I have more derived variables than, you know, actual variables in the data set. So it's been nice to kind of get through and have my own general sense of own derived data set. So that's been nice, but definitely taking the time to review the data and just making sure you really go over that is very important with it. It does take a while, but it's worth it in the end.
Yeah, no, I think that's a really good point. And I think it's true as well for all the clinical teams that are on too, to make sure that you really do think about the CRF, because there are multiple angles around the shock presentation where we ask about similar things in different parts of the CRF. They're not identical, but they're similar, and you really want to think through with your statistical team where you want to pull the data in, and understanding the data structure as the clinical team is pretty important too, as you're working with your statisticians. And I'll say too, as Michael was talking about the macros, we, you know, I also was lucky to work on the COVID registry that AHA supported. And there we did a lot of sharing of code between different projects. And if we haven't made that a possibility so far in the cardiogenic shock registry, I think that's something we can pay attention to so that people know, for example, the terrific macros that Michael has built. That might be something that's useful for others too, so that you don't have to reinvent the wheel, and we can certainly help support that. That's part of the beauties of the PMP. I don't see any new questions in the chat, so I think we will thank Michael again. It's definitely great to hear just how easy it is to work within the PMP. And now we'll turn things over to Kylie, who will give you that 30,000-foot overview of really the key pages in the CRF, just to get you thinking about the data structure and how you might approach some of the analyses you're interested in. So Kylie, it's all yours.
Awesome. Thanks, Dr. Morrow. So today I'm going to walk through the CRF in our live demo environment. So this is the IRP tool that you're seeing. So all of the great elements that you guys utilize are housed here. And I work on the cardiogenic shock registry specifically. So all of these elements are built with our team here at HA. So just for the sake of time, I'm not going to go through every tab here, but just to orient you, as abstractors are in here, they would start with a new patient, and then they would enter in any of their demographic information here. And then once they were done with that tab, they could go to their admissions tab, enter in all the information here. But today we're going to focus most of our time on the shock onset tab, the MCS tab, the ECMO tab, and the serial shock assessment tab. So starting with this shock onset tab, we're just going to run through the variables that you see here on the screen and kind of how that abstraction workflow works. So the first element that abstractors would see is the certainty of shock etiology. So was cardiogenic shock a clear contributor to the shock state, or was it suspected but with some uncertainty? Where was the onset of shock? So did it occur at a participating hospital arrival, while in hospital, or at a referring center? Was there a cardiac arrest prior to shock onset? Yes or no? What was the most favorable neurological status after the arrest? So they could enter in any of these single values here. Of course, we'd want to know that onset of...
I'm just going to break in for 1 second, just emphasize some of those key variables that you show, because those are likely to be important filters for analyses you might do. That first one about shock etiology, we allow that so that there's some patients where we know it's shock, but we're not 100% it's cardiogenic shock that still get entered. And so this, if you want to use a really pure cardiogenic shock group, you may want to collect that and use that as a filter so that you're only using the patients that have a cardiogenic shock as a clear contributor. And then also cardiac arrest is also a very important variable as to whether patients are presenting post-arrest or not, that may impact their lactate level and their clinical severity of illness, and have some elements that can masquerade as shock. So that's going to be another one that's important for teams to think about is, do you want cardiac arrest, yes or no? And do you want to drill down to the subset where cardiogenic shock has a higher level of certainty? Thanks, Kylie.
Of course. The next one here is the onset of shock date or time. So you could enter in that information here. And then the next two are focused on a multidisciplinary shock team and their involvement. So was there involvement, yes or no, as well as the time frame. So was it within 3, 6, 24, or greater than 24 hours of shock onset? The next two look at the SKY shock stage at onset. So we have two different time intervals here for that shock stage. So the first 6 hours, so you could complete that single select here, and then 6 through 12 hours. So we'd want to capture both of those. We also look at presenting physiology and the shock category. So we have those single selects here. And then the last one in this section is etiologies and contributors to shock. So we have all of these different multi-select options that you could choose from. then the last thing on this page that we capture is the medications administered at the onset of shock. So again, another multi-select here. They could select any of these medications captured at shock onset. So then from there, just to note, a lot of our registry has hide clear elements. So in order to see this MCS and ECMO tab, it would actually be built out here in this in-hospital tab. So you can see in this test patient that I have, the MCS device is checked, meaning that's going to pop open this MCS tab here on the right. So once you complete the date and time of the first MCS device, you'll have the opportunity to enter in a percutaneous assist device. So you could select any of those here. Selecting VA ECMO opens up this ECMO tab that you see here. And then as you can see, since I selected Impella and VA ECMO, the nice thing here in the tool is that it populates it for you automatically on this MCS tab. So VA ECMO is selected. And what we're looking at for these specific devices, we have a date and time of implant for the procedure. If the patient died with an implant in place, yes or no. Device explant date. And then we're going to look at the actual location of the implant site. So you can see here on this patient, they had an arterial left, and then it will open up more specifically where that occurred. Same thing with the venous implant site. And then the last two questions, was the patient receiving CPR at the time of implant, yes or no, or unknown? And then what was the reason for device implant? So you can have all of these multi-select options here. And then as a, go ahead.
Yeah, no, I'll just say, Kelly, that you can appreciate, and Kelly will show this for Impella as well, that we capture a substantial amount of detail around mechanical circulatory support that we think will be important for many of the analyses. And functionally, we capture every device that goes in and out and when it went in and out, so that you really can understand the sequencing of devices as they go through. And you'll see in a minute that on the ECMO form, we actually capture an even greater amount of detail about ECMO that we think are quite relevant to ECMO-specific analyses that may be done.
The other one that we selected on the previous page was Impella. You can see we didn't select IABP here, so we're not going to see any elements pertaining to that specific device. But for Impella, you'd actually go in and specify the subtype as well. So here we have an Impella CP selected for this test patient. And then as I just showed above, it's the same questions as we saw. So date and time of implant, if the patient died with the implant in place, explant date, the location, if the patient was receiving CPR, and then those reasons for implant. So that's a quick run through of the MCS tab. So now let's go to this ECMO tab here. So the first section we're going to look at is pre-ECMO events. So you're going to select any current devices that might be supporting the patient pre-ECMO. So you have these multi-select options here. The circumstances of ECMO cannulation. Was a GCS assessed or not? For this particular patient, we checked it was not assessed. That's why you see that here. You also have the opportunity to enter in an ELSO record number. So if you selected yes, you could enter in that number here. For the vascular access section, you'd enter in the date and time ECMO started, and then it gives you all of these specific information that you could enter in. So we have cannulation anatomical site that you could choose from, all these different drop-down values, type of cannulation, the purpose, the size, the manufacturer. You can see again, there's a lot of different drop-downs here. And based on the manufacturer that you select, you would get the model type specific to that manufacturer. The date and time of insertion, and then was the cannula removed for a reason other than death, yes or no? And then this specific section is a repeat group, so that just means that you can add another instance if there were multiple you'd like to enter in information for. And then the next section is our LV decompression. So we'd want to know the procedures and select all that apply here. And then once you select that procedure, it'll open up the date and time for you to complete. And then the rationale for decompression on ECLS. Those are single select values here. The next section looks at cannulation location, so where did this occur, as well as what team members were performing the cannulation. Continuing down, we're going to look at the circuit and components. So what was the pump manufacturer as well as the name, and that operates similarly to what we saw above with the drop downs. Was a common device used, yes or no? A console drive manufacturer name as well as an oxygenator manufacturer name. What were the safety features incorporated in the ECMO circuit for this event? So we have multi-select here as well. And was any component exchanged or replaced, yes or no? And then in this section, we're looking at neurological injury or events detected during or after ECMO. So as you can see here, they're all yes, no elements. If you select yes, like in this specific patient for cerebral microbleed, you'd be prompted to enter in that date and time there. Other complications and events, so any device-related events you could have a multi-select for, as well as any other ECMO complications or events. And then the last thing on this ECMO page is the outcomes. So when did ECMO end? You'd enter in that date and time here. A saved score you could enter in, and then the reasons ECMO ended, another multi-select here. And then the last tab, I'll just, go ahead, Dr. Morrow.
No, I was just going to say it's a remarkable CRF you built, Kylie. It really is. It's everything you would want to know about ECMO, but we do think that that's quite important, so that there's a lot that we can learn in the context of VA ECMO, principally for cardiogenic shock. And we definitely have a rich data set there for you to use for analyses if ECMO is an interest of yours. Great, and our beloved serial forms. So
yes, so I'll run through this last tab here that we're going to cover today. So this is our serial shock assessment. As you can see here, this is another repeat group, meaning you could enter in multiple. So for this assessment in particular, we have up here that we'd like for you to enter data 24 hours from the onset of shock and every subsequent 24 hours up until 72 hours after shock onset or arrival at your site. So typically that looks like 3 per hospital. So for this specific patient, I'll kind of run through the 2 that are here right now. So of course, you'd start with the date and time of assessment. You'd enter that in here, and then it actually automatically calculates the hours it's been since shock onset, which was captured earlier in the form. We'd want to know the SCI stage at that serial assessment. And then we have a couple of yes, no values here for if there was a presence of PAC, mechanical ventilation, and renal replacement therapy. And then below, we're going to capture a couple of different measurements. So we have blood pressure, heart rate, CVP, RA, PA pressure, systolic and diastolic, PCWP, and cardiac output. And then based on these elements here, it will automatically calculate these 3 here below, as you can see. And then lastly, we're going to capture peak lactate, lowest pH, and then the peak out values. We also want to look at vasoactive medications at the time of assessment, so you could select any of those here, as well as the presence of an MCS device. And if you selected one of those, you'll have a few additional elements below here. So, for example, was there a device upgrade or escalation since the prior assessment? Was there a device de-escalation? And then select any reasons for device de-escalations. You could select those here. Was there a vascular complication requiring intervention, yes or no? And then what complications of ECMO were there, if any? So that is one whole serial assessment form. And then as you could see here, there's another one below that they can just add instances for. So same questions, but like I said, we just want to capture at least 3 every 24 hours up until that 72-hour mark. So I know that was a pretty brief overview of what you see on the CRF. Anything else you'd like to add, Dr. Morrow?
Yeah, so certainly encourage people, if you do have questions, throw them into the chat. I'll say that this ends up being a very important form for any analyses that you're doing where you are interested in capturing the clinical trajectory over time. You'll need to use the data from the serial shock assessment. And also if you're looking to see if they're, for example, the worst lactate that they had, you're going to need to be able to pull that data from this form as well, because there'll be serial assessment of labs, serial assessment of the hemodynamics if you have them. Also, as Kylie pointed out, you'll get the new devices, device-related complications. All of those are quite important, and they live within this serial assessment form, which can be used to map out the trajectory of a given shock admission over time. And that's its research value, but while we're on the topic, I'll just emphasize too that for the quality improvement efforts you may be making and the data that you're collecting at your site for your dashboards, this can be very valuable. And as Kylie pointed out, you can collect this as often as you want. And so if you really wanted to see how you were managing your patients for the first 12 hours every 2 hours, you could actually use this form to do that. And that isn't a requirement at all of the registry, but I know from interacting with many participants over the past few days at the heart sessions and also at TCT that many were interested in drilling into that kind of data for their quality improvement efforts. And this is the form you would use to do that. So please make sure for those who are the clinical teams that you're using this to the best of your ability at your site to capture the data. And because it's a repeating instance, you can really use it quite frequently if you choose to do so for all of your admissions. So no, thank you very much, Kylie, for that overview. And I'd say maybe the only other point I would make outside of these forms that we spend some time on is that we certainly capture a pretty robust amount of detail about the cardiovascular history as well. So you'll have all of the heart history variables that you may need to use for any analyses that you're doing. Kylie showed you the demographics, which are certainly comprehensive as well. And so you really do have a good amount of both data about the presentation, the patient's comorbid conditions, and their past history that you can use for the analyses that you're going to do. So thanks very much. We'll have you stick on, Kylie, just in case there are any other questions as we go to the end, but we can go back to the slide deck now. All right, and so, you know, the point of this series of webinars is really to empower you to have all the tools you need to be able to leverage the work that you're doing for all of those on the line who are entering data into the registry to help us learn as much as we can to advance this field. And if you go to the next slide, our goal is to help you. And so there are opportunities for mentorship by subject matter experts from the steering committee and the American Heart Association team. So please always, if you have interest in a specific topic, develop a proposal, submit it. You'll be paired with mentors from the Research and Publications Committee and maybe even the steering committee, where if there's scientific merit and it doesn't overlap with other projects that are already underway, that project could move forward, as you heard during the last webinar. And then we'll work with you to help refine it and make it as strong as possible. The HA staff are terrific. It really is an amazing team that's involved in this registry, and they're around to help you if it's questions about the PMP specifically or the data set. We will conduct, I think we mentioned this in the first webinar as well, but we'll help you with feasibility queries. So if you have a question, but not quite sure if there'll be enough patients or the right data to answer it, we'll do a preliminary look for you to see whether there's the right substrate there in the registry to help you with that question. Or we'll let you know if not, so that you don't spend time conducting analysis that will never have adequate information to come to any conclusions. And it is really important, as we've talked about already, to work closely have a good partnership between the statisticians that are on the line and the clinical teams, so that you can work together most effectively to use your data on the precision medicine platform. I must say that I'm very grateful to have Michael on our team. He's learned immense amount about the registry, and really helps guide us toward better analyses and a better way of approaching the data as we go through. And definitely there's a give and take as we help educate him too on specific nuances of cardiogenic shock that influence the way we use the data that may not be intuitive. So it's really important to have that crosstalk. Next slide. And so last time you heard about developing a proposal and how to submit that proposal. Once you have a successful proposal, here's what's next. First, you need to execute a data use agreement and non-disclosure agreement with the AHA to allow you to have access to the data and proceed with your project. Then you can request the data set and the workspace on the PMP, just like Pratik walked you through, and then you're ready to go. You're ready to start analyzing within the PMP using all the tools that you learned about during this session today. Next slide. And then for those of you who have a question in mind but haven't put it to paper yet, we are currently in our last cycle for this year for research proposals for the Cardiogenic Shock Registry. You can see on the left that the due date is November 30th. After your turkey has worn off. To be eligible at this point, you need to be participating in the registry and contributing. So your site needs to be a participant, and you need to complete entry of at least 50 patient records. So if you're close to that at your site and you haven't done it yet, you can get over that hump during this month. And then we'd be pleased to consider a research proposal from your site. And then on the right-hand side of the slide, you see the standard submission cycle that all of the Get With The Guideline registries are aligned with. And we will be moving to that standard submission cycle as well for the Cardiogenic Shock Registry. So you'll have two opportunities in 2026 as well, if you're not quite ready for this November deadline to submit your ideas. Next slide. And then just to remind you that we are halfway through this research webinar series. For those of you who missed it, the how to build a proposal, it is recorded, so you're welcome to go back and view that. Today, we really tried to give you the nuts and bolts that you might need to access and use the PMP. And please download the slides and walk through them slowly. And the resources that Pratik told you about. If you have any questions, just reach out. Upcoming, it only gets better. We have an abstract preparation and presentation program that will walk you through how to prepare your best possible abstract and get it ready for presentation at a scientific meeting. And Joanne Lindenfeld is going to do that. No one better in the field. And then Sunil Rao will take on part 4, which is how to prepare a manuscript. And this is from a journal editor to give you a guide as to what journals are looking for and how to put your best foot forward with a manuscript that's likely to attract attention and really be able to impact the field. So we really want to help you soup to nuts with the whole process through this series of webinars. And if we go to the next slide, and then lastly, For anyone on the line who isn't already participating in the Cardiogenic Shock Registry, but you're interested in doing so, you can use the QR code that's up on the slide, or just simply go to the heart.org, the AHA's website. And if you go to heart.org, cardiogenic shock, really everything you need is there. And then our terrific team at AHA will reach out to you to talk about your site and potential participation in the registry. So with that, we will open it up. If there are any final questions for any of our presenters, we welcome you to come on. I'll say that we are working through the missingness that Michael described, and I'd say that the vast majority of that is really intentional, and that's why it's quite important to understand where there's branching logic in the CRF. So if you didn't have a cardiac arrest, then we don't ask all the cardiac arrest questions. If you didn't have a certain type of mechanical support, then we don't ask those. There's some that are based on the patient being alive at the end of the hospitalizations, and others that we ask if the patient passed away. And so it's very important to understand the data set. And really, as a kudos to all of you who are working in the registry, overall, our completeness is well above 90% of records, that we have more than 90% of records are more than 90% complete. And so actually, we really are very pleased overall with the data quality in the registry, and that will put you in a good position for analyses that you want to do.
Dr. Morrow,
yeah, please.
We do have a few questions.
Sure.
One is, will the hospital of initial presentation be available?
Yeah, so there is a transfer form that is a transfer module that is in the CRF that allows you to capture the initial receiving hospital that may have transferred to your site. And thank you for that question, because we actually think that is a very important issue. We are very interested this year in working on understanding the systems of care for shock and how regional shock networks are working and what the referral patterns are that can help us understand, are we facilitating patients getting to tertiary and quaternary centers, expert shock centers quickly enough, which many of you are. And so please do look at that transfer form. It'll capture the transferring hospital as well as some important detail about the patient's status and what they did to care for that patient at the initial hospital.
Great. We have two questions that came in during Kylie's presentation. The first was, is there no mention of out-of-hospital cardiac arrest versus in-hospital cardiac arrest?
Yeah, no, we should be differentiating between the two. I will let Kylie take a peek and feel free to add anything from that page. But because we also collect the time, I believe, that will also allow you to relate it to the time of hospitalization.
While Kylie's looking at that, I'll go to the next one.
At any time if she has that.
Yes. Which CO do you use for patients under ECMO pump delivered?
Yeah, and so for the cardiac output, we want to capture the overall estimated cardiac output is what we're looking for. So if you're using thermodilution or FIC, we want to capture the total estimated cardiac output.
Okay. Last question that I have here is, how do you calculate the SCI class? And then another, I'll let you answer that, and then we'll go to that next question.
Yeah, no, that's a great question. So the SCI determination, we're actually asking for your clinical assessment from your site. And if you look at the coding guidelines, it will walk you through the SCI classification, which goes from A to E, with A being at risk. And actually, For most of your patients in the registry, you won't see an A because we're actually capturing patients that are generally C or higher, though you may have some B. B is for beginning. C is classic cardiogenic shock, where there is usually a low blood pressure or you need medications to support the blood pressure. And then you have some evidence that there's hypoperfusion of the organs, lactate being the most common, but it could be the physical exam with cold extremities, could be low urine output, it could be liver injury, any of those. D is deteriorating, and then E is extremis. And the guidance from SCAI for those SCAI shock categories are in the coding guidelines.
Wonderful. I have one more. How is the PMP being used to develop predictive models for cardiogenic shock outcomes?
That is a terrific question. And I'd say really it's up to all of us. The PMP is a platform that allows all of us access to the data. And so we do have proposals already. There's a machine learning proposal that's developing predictive instruments for outcome prognostication. But there are others that we could use. You could try to develop predictive instruments for clinical deterioration. You could try and develop predictive instruments to discriminate between different contributors to shock among the shock categories, for example. So we anticipate that there'll be many other questions that we can ask, and it'll be very much up to you. But the PMP is definitely a platform in which we can use machine learning approaches to use the data.
Kylie, I see that you did answer the in-hospital versus out-of-hospital. Did you want to come online and let everyone know that answer?
Yeah, come on in.
Sure, I was just typing it. We currently only collect it at your facility, but we can look at enhancing, our CRF in the future to capture more conditions at transfer.
Yeah, I think we do still have presentation with cardiac arrest, but you're right. We will look at the granularity to make sure that we're able to distinguish a cardiac arrest that's in hospital prior to shock onset versus a cardiac arrest that's out of hospital prior to cardiogenic shock onset. We definitely want to be able to discriminate between those two, and I think that we can with the data that we collect, but I love the questions at these meetings because they always make sure that we have everything we need, and we will take a look at that to make sure we are. And I really appreciate the flexibility and of the HA team that has been making multiple upgrades as we've been going to the CRF. And so if there's something new we need to add, we can do that in the next release.
All right, we have
Melissa, any last burning question?
One more minute, and I have one last question. Can PMP data support the development of novel therapeutic targets or clinical trials in cardiogenic shock?
Well, that's an interesting question. I would say that the data that we use and the analyses that we can conduct may very much lead us to hypotheses for new strategies for managing shock that then we would need to test. And I'll say we are very enthusiastic about using the registry to actually support clinical trials. And that is, we actually have a work group that's dedicated toward developing trials within the registry. That isn't specifically built into the PMP as it is. The PMP will help us analyze the data to develop the hypotheses. And then if we do run a clinical trial, undoubtedly we'll also use the PMP as a way to share data from that too. Great. Well, thank you all. We are at the hour. We really appreciate all your questions. Was there anything else, Melissa, you wanted to close with?
I'll just close with, once you leave today's webinar, you'll receive an email with a short survey. If you could fill that out, that would be great. We would love your feedback. I'd like to thank all of the panelists and all the attendees today. We appreciate your time. To the panelists, we appreciate your support of the AHA. Thank you so much.
Thank
Have a
you.
wonderful day, everyone.